Hello everyone. Today we're going to talk about the surface area and volume of prisms. So let's review what a prism is. If you did your nets homework, then you'll see, how do I make this thing work? Here we go. Here's our rectangular prism. And you can see I actually did the homework there. I wrote in for the rectangle, it's length times width. And that means for the square, that side is a width. It's a W. So instead of side squared, I use W squared. So we have 4 rectangles, 2 squares. So the surface area is going to be 2 times W squared plus 4 times length times width. So we're just finding the surface area of every side and adding it together, right? Here's your triangular prism, same thing. Now I want to caution you guys, you're not supposed to believe your eyes. That triangle height is not 3. That does not go fully up to 3. So some of you calculated the actual surface area, multiplied out all those numbers, and you used 3 there on that one and also on our square prism, or our square pyramid rather. Be careful, you still cannot trust your eyes. I had to make those triangles a very specific size in order to get them to match up when you folded them. So careful on that one. But there's our triangular prism. And so you've already done some work with prisms, and we're going to look at some more examples of prisms. So I want to show you, here is a square prism. I'm sorry, it is a rectangular prism. That's a rectangle. It has squares on the ends, and then it has rectangles all the way around. So this is a rectangular prism. A square prism would be something that has all squares every side. All squares every side. And we've talked about that. If you go back to the document called Explain Solids or the matching video, we talked about square prisms, also known as anyone? Cubes. Square prism is a cube. A cube. All right. So we have a square prism is a rectangular prism, just special because its rectangles actually are squares. So this looks a little familiar. Pretty much like the one you've got in your notebook when you did your net. I want to show you another one though. Is this a prism? Is it a regular prism? Remember, if you go back to Explain Solids, we talked about regular prisms and what's an irregular prism. A regular prism has top and bottom the same. So in the case of this rectangular prism, the top is a square, the bottom is a square, they're exactly the same, and then it can go up as tall or as short as we want it. So this is a regular solid, it's a rectangular prism. Is this one? It is, because think of it here, actually we've got a rectangle going all the way around 4 sides. And then we have a top that in fact is a square, and a bottom that is that same square. So if you look at it this way, you might say, well, the sides aren't the same. I've got a rectangle here and a square here. Completely true, but turn it this way. Now you've got squares top and bottom, and you've got rectangles all the way around. So this too is a rectangular prism. Now, there was another kind of prism on last week's homework, a triangular prism. And I tried to make those easier for you. We just talked about it. We had to be careful that we could not assume that that triangle's height was exactly 3. In fact, it wasn't, because the rectangles that I drew, the side here was 3. The side here was 3. The side here was 3, which made this what kind of triangle if all 3 sides are the same? Equilateral. And we know that if an equilateral triangle has all sides of 3, its height is also not 3. Its height's not 3. So for those of you who jumped ahead and thought to calculate the actual numbers there, the height was not 3. So don't believe your eyes and be careful when you're looking at shapes. Not everything's drawn to scale. Those were drawn to scale. If you cut them out and you put them together, you should have been able to fold up those sides and that triangle on the end and get this triangular prism. And here's an example of another triangular prism. And what's cool about these prisms is that their triangles are equilateral. So this particular triangular prism has a rectangle. This particular triangular prism has a square as a side. So still length times width, but the length and the width are the same. So these are somewhat special in that they're equilateral triangles on the end. Okay, but all of the faces, and we call these lateral faces. So if you look at them from top to bottom, the triangles are the top and the bottom, and then the up and down sides are called lateral faces. Lateral faces. And those lateral faces, in this case, a rectangle, in this case, a square. So we did already talk about cubes. And we, again, if you want to go back to, in general, what's volume, what's surface area, how do we know how to calculate those? Look at that document that's in resources called Explain Solids, or you can rewatch that video. And those resources, you will have to back up in RenWeb a week because I expired those resources. So you don't have a list of every document I've ever uploaded. They have time limits on them. So you'll have to back up to last week, then choose documents, and then it'll be there. Explain Solids is where that was. So what I want to do is look at, first of all, we're going to do some IXL this week. So let me share what that's going to look like. And the unique thing about IXL this week that you guys don't always get, where is IXL? Sorry guys, let me go back to where IXL is. I think I have too many windows open. Share screen. There we go. We're going to be doing in the Geometry tab, Surface Area and Volume T1, Introduction to Surface Area and Volume. And the unique thing this time about doing IXL is that I only need you to get to score 60. When you get past score 60, you're going to see some variables, X's and Y's, in the heights, excuse me, and widths of your figures. So you only need to get SMART score 60 this time or run for 10 minutes. Now, if you go for 10 minutes and you don't have a great score, you're going to want to go back and continue on. You can always do more minutes, but you need to have a decent score here to make sure that you're understanding this. So when we're looking at the surface area, I know the bottom of this figure is a 4 meters by 4 meters. So in my calculator, I found it. It was in the classroom, in the drawer, right where I left it. 4 times 4 is 16. So I know that the area of the bottom is 16. Well, I know the area of the top is 16, or it wouldn't be a regular prism. So 16 plus 16 is 32. But now let's look at the sides here. This happens to be also 4 meters up. So this is 4 by 4 by 4, and just looking at it, don't believe your eyes, but it is a cube. So if I have a 4x4 side here, that's another 16 on the back side here, 16 on the back side here, 16. So in fact, if I take 6 times 16, I get 96. 96. So let's put that in. And there we go. What's the surface area? 9 by 9 by 9. Now guys, make sure when you're doing this, this is introduction to surface area and volume. So make sure you're looking at what they're asking for. When I did this, I missed a couple because I was giving volume instead of surface area. So surface area, again, this is a cube, not just because it looks like it, but because this is 9, this is 9, this is 9. So we know the bottom is 9 times 9. That's 81. And we know the top also is 9 by 9. And we know all 4 of the sides are 9 by 9. So if I take 81 times 6, I'm going to get the surface area of this cube, which is 486. All right, now we've got volume. Volume, so easy. It's the area of the base. Again, we've got a cube, not because it looks like one, but because it gives us the dimensions that shows it to us. It's just the base, area of the base. So area of the base is 9 times 9, 81, times the height. How tall is this thing? So in our example, triangular prism, the base times the height. So that's 9 times 9 times 9 is 729. Now this is volume, so you can see here it says cubic millimeters. And fun fact, because I have a chemistry degree, cubic millimeters is milliliters. Have you heard of milliliters? You've heard of liter, like a liter-sized Coke. A milliliter, actually, my Diet Coke here, is 355 milliliters. A cubic millimeter is a milliliter. All right, again, what's the volume? It's the area of the base, 7 times 7, times another 7 height, 343. All right, what's the volume of this one? Area of the base. Area of the base is 6 times 13, which I don't know off the top of my head. And then we multiply that by the height. This looks exactly like this one. Now, not exactly like, because this is a square. And we don't have a square here, we have a 13 by 10. 6 times 13 times 10, I get 780. Okay, this is why I don't want you guys to go too far in this one, because here's where it gets hairy. For surface area, we're going to look at what's the area of the bottom of this. The bottom of this is 18 times 15, 18 times 15. The top is the same thing. So we can take 18 times 15 times 2. But then we've got these little side pieces here. We've got one here and one in the back. So we need to add 2 times the 3 times the 15. And then we've got these side pieces here that are a little longer. Now they're 18 by what? Up and down. 3. So we're going to add 2 times 3 times 18. Let's see if that's right. 738. There we go. Surface area. Now, if this was volume, it'd be 11 times 11 times 11. We'd be done. But this is surface area. Surface area. So 11 times 11 is the area of the bottom and the top. So let's multiply that by 2. And then we've got 11 times 11, 4 more times. So it's actually 11 times 11 times 6. 726. Volume, easy. Length, width, height. 9 times 9 times 9, 729. Now remember, when you're doing this on paper, don't forget your units. Volume again, easy peasy. Length times width times height. 15 times 15 times 15, 3375. And one last time, surface area, again, this is a cube. So I've got 6 different squares here that are 28 by 28. So 28 times 28 times 6, 4704. Okay, so as you do IXL, you can continue on as long as you don't see an X or a Y. I think it's good practice for you to look at the surface areas. Okay, you just have to think of each side, what's the length times the width, and then add all 6 of them together. There will always be 6 sides. Okay, so let's switch over to our homework for the week. And that is on prisms. And so here's our homework on prisms. It's called Bases and Faces. And that's explained a little bit in part C here. And I mentioned it earlier. A prism is a solid and 2 of its faces called bases, in our case the top and bottom, are congruent. So here's our prism. The top and the bottom are congruent. They're the same. In our case, it's a square. And the prism must also have sides that connect the bases, and these are called the lateral faces. So these are the ones that include the height. Okay, those are lateral faces. And the faces have to be parallelograms. So they're rectangles, squares, rhombus, or a regular old parallelogram. So if we took this and kind of smushed it sideways and bent it over, it would still be a prism. It would still be a prism. And we'll have an example of that a little later. So if we talk about the volume of Paul's tower, he built a tower by stacking 6 layers, and I highlighted that because over here, it doesn't tell us how tall this is. There are no markings here. So I want to make sure you know it's 6 layers of this shape. So if we want to know the volume, we just have to know the area of the base, multiply it by the height. We know the height's 6. But how do we know the area of this base? It's some wonky shape here. Well, we're using units. We're using units to do this. And so we don't need inches or millimeters. We don't have to know. It's just like when we did our Rubik's Cube. We said we'll use Rubik's units, and it was 3 times 3 times 3. Here, we're just looking at units, and we're just going to call this a single unit. And this over here, a single unit. So if I take 1 times 1, I get each one of these squares. The area of 1 times 1 is 1 unit squared. And so how many 1 unit squareds do I have? I have 3 in this row, I have 2 in this row, and I have 2 in this row. So that's 3, 4, 5, 6, 7. I have 7. I have 7 in my base area here. 7. Now we said volume was just the base area times what? The height. So the volume here, how high is this thing? They told us 6. So 7 times 6 equals 42. 42 what? Units, and you can abbreviate that with UN if you like. Units what? Just units? Units squared? Units cubed. We went 3 dimensions. We went from this square right here, which is a square unit, and multiplied by another unit over here. So that's units cubed. Volume is always cubed units. It's either millimeters cubed or centimeters cubed or inches cubed. It's units cubed. So what's the surface area? What's the surface area of this tower? Now this is a regular prism. Its top and bottom are the same, but it's not like the kinds of prisms we've been working with, where we can just say, hey, this is a rectangle, this is a square, I know those formulas, let's move on. So this is a little tougher. And so here's a little trick. If you can find the area of, say, the top layer, say this is the top layer of Paul's little building that he built. Kind of looks like one of those fancy office buildings that aren't just straight up, right? That matches this top layer right here. So if we think of this top layer, we already know that the area of that top layer was 7, right? There's 7 blocks. It's 7 units squared. So I have a top and I have a bottom. So now I know my surface area is 7 plus 7, top and bottom, plus, now what? I've got all these others. So this is 2 wide, but it's 6 tall. This one's 1 wide, but it's 6 tall. This one back here is 3 wide, but 6 tall. What do I do? Here's the shortcut. To get the lateral area, remember, lateral area, you've got a top and a bottom. You get those 2 areas, they're the same, add them together. The lateral area is simply the perimeter of the top or bottom. The perimeter, the distance around, times the height. We know the height is 6 units. So what is the perimeter here? What's the perimeter? Well, it's 1, 2, 3 this way, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? If I just draw all the way around there, in and out of those little corners, the perimeter is 14. So if I take 14 times 6, that's going to give me the lateral height. Remember, lateral faces are the ones that aren't the bases. So bases is top and bottom. And lateral faces are the ones that go up and down. So my lateral area is 14 times 6, which is 84 units squared. So if I add on the 84 and the 7 and the 7, I get 98 units squared for the surface area. So still calculate the area of the bottom and the area of the top, but when you need to know what the lateral face is, what's that area? You could individually do it. You could say this is 6 times 2, so that's 12. This is 6 times 1, so that's 6. There's another 6 times 1, that's another 6. You can do it step by step all the way around, but the shortcut is find the perimeter, and the top and the bottom have to be the same or else it's not a regular prism. So find the perimeter of the top or the bottom, multiply it by the height, and that gives you the lateral area. Add that to the top and bottom, and that gives you the full surface area of that object. All right, So remember, at any time, if you want to fast forward or back up or pause to take notes, you can certainly do that on this video. So part C here isn't really a question. It's just those definitions of prism and bases and faces. But then we have questions 1, 2, and 3 for each of the prisms below. Find the volume and surface area. You'll do that exactly like I just did. So for problem number 916, we have A and B, and then 1, 2, and 3. So 916 is a homework assignment. That's going to be worth 5 points. On 928, we're going to look at this solid, and we're going to undo it. We're going to make it into a net. So last time we started with a net, and we made it into a solid. This time you're going to have a solid, and I want you to draw it out on your graph paper and break it open. What would it look like? What would it look like if you broke that open and drew it flat in your notebook? And then once you do that, find the surface area and volume. And then for 929, we're talking about triangular prisms. We've seen those before, the triangular prism. Now the triangular prisms we've seen have been equilateral triangles at the end, and squares or rectangles through the sides. They've been equilateral triangles. In this case, we've got a triangle that's not equilateral. It's okay. It's still a regular solid because the bottom and the top are exactly the same. And you're going to find the area, the surface area, and the volume exactly the same. You just have to use a different formula here, right? What's the area of the top? Well, the area of a triangle is 1/2 base times height. So you're going to do it very similarly to what you did here. And to find the surface area, you're going to want to add up the perimeter. Now we don't have what this side is, but it is a right triangle with sides of 3 and 4. So there's a way for you to figure out what that hypotenuse is. So figure that out, add them together, multiply by the height, that gives you your lateral faces. All right, so you're going to find the surface area and then also the volume. And then the final question is for honor students. This is a real life triangular prism I found on the internet. Toblerone chocolate bar, which you see in the airports for some reason. Like you don't see them at Walmart, I don't know. Anyway, I pulled the real dimensions of the Toblerone box off the internet, 30.6 times 5.4 times 5 centimeters, and I need you to find the surface area and the volume, and that'll be a separate 4-point question for you. So 5 points of IXL, 5 points for question 916, and then 5 points for 928 and 929 together. As much as you can fit on one picture in your notebook and upload to Homework Drop is fantastic. If you need to do 2, that's fine too. You can always put your pictures into a Word document, or I'm sorry, a Google Doc, and share it with me that way. No problem. And I think that's all I have for you. Now, homework this week is due on Thursday, which means there is a separate assignment on Friday. Friday, what we're going to do, we're going to turn everything in on Thursday by 11:59 p.m. So just before midnight on Thursday. And then on Friday, we're actually going to have another video, and you will find your own prism in your house and make a net. So here are a couple that I found. Here's a prism. It's got squares on the end, really long rectangles. And then here are my generic Pop-Tarts from Walmart. It looks like I've got maybe a rectangle. Doesn't look like exactly a square there. And then rectangles around the sides. So that'll be another project that we'll do, and there'll be a video that goes with that. If you have any questions, remember office hours are 12 to 3 on Zoom, and the Zoom link is in RenWeb. I don't post it anywhere else except in RenWeb. If you cannot access RenWeb, please let me know and I'll email it to you. If you have any questions, all of my contact information is always, always at the top of these documents. My Google Voice number, text or talk, comment on my blog, WeChat ID. I actually don't get notifications from Instagram, so I wouldn't go that way. Or you can request a Zoom. If you open your Zoom, you can invite me to a meeting and I'll get a pop-up that says someone's trying to talk to you. So as always, I'm available from at least 9 to 4, usually earlier, usually a little later. So contact me if you have questions, and good luck this week.